Good morning, students. So now we are going to see some example on Kirchhoff's current law and voltage law. All right. Let us look at this example wherein you have to determine the Vx in the circuit. All right. So Vx is the voltage across the current source. So for this circuit, now let us start the solution with by assuming the current voltages and currents in various branches here. All right. Already in the problem itself, they have given 5 amperes current in the 8 ohm resistor, and here I have assumed the voltage across 8 ohms as V8 with polarity plus and minus here, and the current in the 10 ohm resistor I assume it as I10 here, right, in the direction downwards, and the polarity when the current is flowing in downward direction, and this polarity, the voltage polarity across the 10 ohm resistor would be plus here and minus here, right? So similarly, I have assumed the current direction in the 4 ohm resistor as I4 here. Then obviously we got the polarity of the voltage across the 4 ohms as plus here and minus here, and we define this as V4. And here also in 2 ohm resistor, I have assumed a current direction as in downwards as I2, right? And the polarity of this voltage would be this plus, here it is plus and it is minus. And the voltage we assume we define it as V2, right? Now, if you look at this diagram, here you have one current source with a magnitude of Ix, and its polarity is already given in the problem as Vx with polarity plus and minus, plus here and minus here. Therefore, and if you look at the circuit, here in the circuit, the current source and the 2 ohm resistor are connected in parallel. Thereby, the voltage across the 2 ohm resistor and voltage across the current source would be the same. That is, we assume it as V2 is equal to Vx. Right now, now with this simple definition of currents and voltages at different branches, now we apply KCL at different nodes. So where we have node here, we have one node, node 1 here, and this is another node we have here. And here in the bottom also we have a node, one node is a common node, and this is a reference node. Generally we call it a reference node. Right. So now we apply simultaneously Kirchhoff's current law and Kirchhoff's voltage law for this circuit. We apply Kirchhoff's current law for the at this node and at this node, and we apply Kirchhoff's voltage law for this loop and for this loop in this direction. Right. Let us we see how the equations would be, right. And the answers we will get after getting the solution. Here it is I have given for your purpose, right. The V10 would be 20 volts and V4 would be 12 volts, and Vx ultimately the Vx would be 8 volts. V10 is this and V4 is this, right, and Vx would be 8 volts. And since Vx and V2 are same and both are equal, now these are the answers. Now these three answers, how we get these three answers, let us look at here. All right, now first we apply the writing the appropriate KCL equations. So what KCL equations we obtain, here it is. If you look at the diagram here, if you look at the diagram, so at this node 5 amperes current is entering and I4 and I10 are leaving. Therefore, I write it as I4 plus I10 is equal to 5. This is one equation we got. All right. Then at this node, if you look at that, I4 is entering the node 2 and Ix is also entering node 2. Then I2 is leaving. Therefore, I4 plus Ix equal to I2, we can write it, right? So the second equation is I4 plus Ix is equal to I2. So this is KCL equation 1 and this is KCL equation 2. Now we write the following KVL equations for two loops as I mentioned earlier. Now for that one, let us once again go to the circuit. This is loop 1 and this is loop 2. Now let us write the equations for KVL equation for this loop 1. In loop 1 we have a voltage source with the 60 volts magnitude and voltage drops of V8 and V10. Therefore, as per the definition of the uh, Kirchhoff's voltage law, algebraic sum of the voltages in a closed loop is 0. So now we'll take the algebraic sum here, and the polarity of Vg we have here, it is minus, and V10 is minus, and this is plus. Therefore, we can write it that as the first KVL equation, we can write it as V8 minus V10 plus 60 is equal to 0. Or in other words, we can write it as V8 plus V10 is equal to 60 volts. This is one KVL equation. Then the second KVL equation, well, how we can write it, here it is. You take this loop right, in this loop. So if you assume it, the loop direction is like this. If you assume it, the loop direction is like this. If you assume the loop direction, if you take it like this, so what we will get here, it is since the current is in 10 ohm resistor, the current is we assume the loop direction is flowing in from -2 plus, we get a plus V10 minus V4 and minus V2 plus V10 minus V4 minus V2, we'll get it plus V10, that is V10 minus V4 minus V2 is equal to 0, or we can write it as V10 is equal to V4 plus Vx, since V2 is equal to Vx, already we have defined it the same, both are since there, and this is another KVL equation we can say, right? So these two KVL equations and two KCL equations we have written and two KVL equation we have written. Now, if you carefully observe that, we can also apply the Ohm's law. Ohm's law for 8 ohm resistor. So Ohm's law for 8 ohm resistor, if you apply it, look at this diagram. 8 ohm resistor is here, right? In this 8 ohm resistor, right? So if you write the Ohm's law, then current is flowing 5 amperes, and therefore the V8 would be 40 volts. So I can write it as V8 would be 5 into 8, which is equal to 40 volts. So by applying the Ohm's law at 8 ohm resistor, now we got V8. Now you substitute this V8 in this equation. Then what we'll get here, it is 40 plus V10 is equal to 60, and this implies V10 is equal to 60 minus 40, it is 20 volts. So once we get the V10 as 20 volts, you substitute that in this equation. Right, then what we will get here, it is that V4 plus Vx is equal to V4 plus Vx is equal to 20 volts. Now in this, if you could able to find out V4, then Vx can be determined. V4 can be determined once again by applying the Ohm's law. Right, right. In this circuit, if you look at the, if you apply the Ohm's law to this branch, then what we get here, it is V4 is equal to V4 V4 is equal to 4 into I4. Right. Then how could we find out the V4? Here it is, I4 can be determined, right, from the this equation, from KCL equation. I4 is equal to 5 minus I10. If you know the I10, then we can find out the I4. What is I10? I10 is the current in 10 ohm resistor, right? Therefore, this can be determined. I10 is equal to current in the 10 ohm resistor. Since we know the voltage across the 10 ohm resistor, now we will find out the I4, right? After determining the I10 as 2 amperes, your I4 would be, since I4 is equal to 5 minus 10, that is 5 minus 2, I4 would be 3 amperes. Once you get the I4 as 3 amperes, then we can find out V4. V4 is equal to, already we have determined V4 is equal to, right, as 4 into I4, 4 into I4, which is equal to 4 into 3, which is equal to 12 volts. Therefore, V4 you got it as 12 volts here. Therefore, once you get the V4 as 12 volts, you substitute it in this equation, right? Then we'll get Vx. Therefore, V4 is 12. 12 plus Vx is equal to 20, and from this one, Vx is equal to 20 minus 12, which is equal to 8 volts. So Vx, we got it as 8 volts, already we defined. V4, we obtained V10 as 20 and V4 as 12 and Vx as 8 volts. This is how we calculate all these three voltages and ultimately Vx by applying simultaneously KCL, KVL, and Ohm's law to this circuit. Now this is how we solve it. Now we'll stop here and we'll continue in the next video. Thank you for watching.